Hi everyone, in this lesson we're going to be discussing probabilities and quantiles, also percentiles, underneath a normal curve. So I've got here an example of a normal curve with a mean of 5 and a standard deviation of 1.5. And we've already seen how to find the area under these curves which represent probabilities. But here's a different question. I would like to know a value for x so that the probability that, and this is my variable x, and this of course represents the probability density function. So I want to know values for x such that x is less than or equal to some number c, and that probability is exactly 0.25. Now, rather than giving you a value for x and asking you for the area, this time I'm asking the other way around. So we need to use our calculators or tables if you have access to tables, but calculators are the modern equivalent. So we go to the stats menu, once again F5 distributions, then F1 for the normal distribution. This time we're using the inverse normal because we've been given the area and we're calculating the value of the variable. So I want the tail to be on the left hand side, I want the area to be 0.25, and I've already set that the standard deviation is 1.5 and the mean is 5. So let's just move down and calculate that. It tells me there 3.99, or very close to 4. So if I were to draw a line almost exactly here, the area to the left of that represents 0.25. In other words, 1/4 of the distribution is to the left of that point. This is called a quartile, often referred to as Q1, the first quartile. So clearly 75% of the distribution is above that. Now let's see if we can find, and what would I do over here? Well, I would write that C equals 3.99. That's what it turned out to be. Now, what if I wanted to know where the probability was 0.5? So this is the area to the left of this point will equal a probability of 0.5. Look at that, it's the value of 5. Now, that's not the least bit surprising, I hope, that the value here is the second quartile, also known as the median. And that would tell me that the area that I'm shading now is also 0.25. A total of 50% of the distribution is below Q2, or the median. It just happens to be also equal to the mean in this case. Now, in general, the median and the mean are not always the same, but in this symmetrical distribution it will be. I think you won't be the least bit surprised when I calculate the next one out. This one here is going to be Q3, the third or the upper quartile. This one will also represent 0.25. And lastly, this part on the right would also represent 0.25. Quartiles split the distribution into 4 equal areas and therefore equal probabilities. That's a quartile. Now, of course, we could have done the same process with percentiles. I could have said, let's have another example. Now, I don't have a nice diagram drawn for this one, so there's a normal distribution. This time, let's make it a bit different. Let's say the mean is 62, and let's say the standard deviation is 12. This might represent the scores that a large group of students got, say, on a mathematics test. Now, I want to find the 95th percentile. I want to know where the top 5% of the students lie. So this area on the left represents the 95% of the population. And the people who are here on the very, very top, I'm going to award them a high distinction grade because they're in the top 5% of the class. So what would I do? I'd come over to here and I would need to say it's a left-hand area of 0.95. My standard deviation is 12 and my mean is 62. Let's calculate that. It looks like 81.7. So my cutoff mark here is 81.7. Anybody who scored more than 80 or got 82 or above, they're in the top 5% of the class. They will get a high distinction. So we would call that the 95th percentile. That's all there is to it, really. You can divide these into percentiles, which mean groups of 100, or you can divide these commonly into quartiles. We talk about Q1, Q2 and Q3. Occasionally we talk about deciles, where we divide it into groups of 0.1, so 10 equal groups. But by far the most common are the quartiles and the percentiles. Okay, thanks for watching. That's all this time.